First of all, see the outlines of this session. Open belt drive, then cross belt drive, then compound belt drive, then quarter turn belt drive, then belt drive with idle pulleys, then step or con pulley drive, and at last we will see about fast and loose pulley drive. Now first of all, start with the classification of the belt drive. So in this figure you can understand the application of belt drive. So belt drive is classified as open belt drive, cross belt drive, compound belt drive, quarter turn belt drive with idle pulleys, step or con pulley drive, and fast and loose pulley drive. So let's see one by one all these types of belt drive briefly. Before starting that, first try to understand exactly the meaning of belt drive, or you can say what is belt drive. So in this figure you can see there are two pulleys, driving pulley and driven pulley, and on which the belt that is mounted. And in this figure you can see this is the driving shaft, and here driving shaft is rotating in anti-clockwise direction, and in this figure this is the driving shaft which is rotating in clockwise direction. So in belt drive, driving shaft can rotate in anti-clockwise direction or can rotate in clockwise direction, and based on that there will be the tight side and slack side. So here driving shaft is rotating in anti-clockwise direction, that's why tight side that is on upper side and slack side on bottom side. Here driving shaft is rotating in clockwise direction, that's why tight side is on bottom side and slack side on upper side. The belt is flexible element. Here you can see it is used to transfer the power from one system to the another system. So here you can see the power is transmitted from one shaft to the another shaft, means driving shaft to the driven shaft. Now let's start with the first open belt drive. In this the shaft rotate in the same direction. Here you can see driving shaft is rotating in anti-clockwise direction, so that driven shaft is also rotating in anti-clockwise direction. The shafts are arranged in the parallel direction. Here you can see both the shafts are parallel to each other. If the shafts are having a more distance between driver and driving pulley, that means from this center to this center, then one side will be slack side, here you can see, and the other side will be the tight side. So if the distance is more, then there will be the effect of tight side and slack side. If the distance is very less, then there will be no effect of tight side and slack side. Next one, cross belt drive. So here in this figure you can see the belt is cross, and that's why it is called as cross belt drive. Here in the cross belt drive, the transmitted power is more due to more contact angle. Here you can see contact angle is more on both pulley, and so that it can transmit more power, but it cannot run faster. If so, then rubbing between belts may wear and tear. In this, the shaft rotate in opposite direction. So here you can see if the shaft A rotates in clockwise direction, then definitely the shaft B will rotate in anti-clockwise direction. So very simple, in open belt drive both the shaft rotates in the same direction, whereas in case of cross belt drive both the shaft rotate in opposite direction. Next, third one, compound belt drive. In this drive, a particular shaft hold two or more pulleys as shown in figure. Here you can see this shaft having two pulleys B and C, and that's why it is called as compound belt drive. So very simple, if any shaft having more than one pulley, then it is called as compound belt drive. In this figure, you can see two views of the compound belt drive, and here you can exactly understand on this shaft there is two pulley 2 and pulley 3, and that's why it is called as compound belt drive. When it is desired to increase or decrease significant speed, the compound belt drive assembly is considered to be the most important method. It eliminates slip. In this combination, pulley B and C are the compound pulleys. That means pulley C is keyed on the same shaft on which pulley B is. So in this figure you can see on the same shaft pulley 2 and pulley 3 are mounted. That's why both the pulleys are called as compound pulleys. The speed of pulley B is exactly equal to the speed of pulley C. So you can say the number of revolution of the B is exactly equal to the number of revolution of the pulley C. Now fourth one, quarter turn belt drive. The quarter turn belt drive, also known as right angle belt drive, because both the shaft are exactly at right angle to each other. It is used with shafts arranged at right angles. Here also you can see both the shafts are at right angle and rotating in one definite direction. So here two views are given to you so that you can understand it easily, and definitely this figure you can use in the examination. Now next one, belt drive with idle pulleys. So here one idle pulley is used, but you can use more than one idle pulley also, and that is sometimes known as jockey pulley. So jockey pulley is an ideal pulley which is used for increasing the angle of contact. Here you can see by using the idle pulley you can increase the rape angle, or sometimes it is called as the contact angle. You can increase power transmission capacity of the drive by increasing the angle of contact. So in short you can say with the help of the idle pulley you can increase the rape angle, and so that you can increase the power transmission capacity of the belt drive. And this is a very simple figure, definitely you can use it in the examination. Here this C is the jockey pulley, or sometimes called as idle pulley. Now next one, step or con pulley drive. So in this figure you can see step pulley is used, and so that it is called as step pulley. This is the 3D figure so that you can exactly understand. Here also you can see the animation of the step or con pulley drive. Here more pulleys of different diameters, here you can see, are attached adjacent to another. And this figure is very simple figure, definitely you can use it in the examination. Here our objective is to transmit the power or torque from the driver shaft to the driven shaft. Step, or sometimes it is called as con pulleys, are used where they have to change speed of driven shaft, change frequently like a machine. It can be lathe machine, or it can be milling machine, or many more. The shafts are placed parallel to each other, here you can see, and they are so aligned that the largest pulley of A falls just opposite to the smallest pulley of the driven shaft. The diameter of all steps of A and B are so adjusted that the same belt can be used to change the speed of the driven shaft. Now last one, fast and loose pulley drive. Here you can see this one is the fast pulley, sometimes it is called as the fixed pulley, and this one is the loose pulley. As the name indicates, there are two pulleys, fast and loose pulley. The fast pulley is mounted on a shaft with keyed joint, and the loose pulley runs freely on the shaft and it is incapable of transmitting any power. When multiple machines are working from a single power source, that is called as the line shaft also, then it is required to stop or run one machine frequently. In this condition, each machine is provided with fast and loose pulley so that you can stop or run the machine as per your desired. If you want to see more engineering videos, then subscribe my YouTube channel and go to playlist. Thanks my dear friends. Press the like button to appreciate this video.